Hey, what's up guys, my name is Cherno and welcome to the 5th episode of my Flappy Bird series. Today we'll be talking about shaders, specifically how we can load them for use in our game. Firstly, what's a shader? A shader is a bunch of code, a program, that runs on our GPU rather than our CPU. Basically, shaders allow us to program the graphics card, which, as you can imagine, is immensely useful for graphics. There are two types of shaders in OpenGL, vertex and fragment shaders. Vertex shaders are used for every vertex of every object we render, whereas fragment shaders are used for every fragment, or basically pixel, of objects we render. This will all make much more sense in future episodes when we actually write these shaders. There are actually more types of shaders, such as geometry and tessellation shaders, but we'll only need vertex and fragment shaders for this game, and most others. Let's go ahead and collapse our math package. We're not going to need to work with it right now. Let's create a new class and put it into a new package, util. This stands for utility, and thus this package will hold all of our utility classes. That is, classes that help us perform common operations. We're going to write our shaders as separate files, so we'll need a way to load in all the text from a file. Let's create a file utils class that will do just that. I'm going to make a private constructor here so that we can't instantiate this class, since it's going to be completely static, meaning we never have any need for instances. Then what we need to do is write a method that will convert a file that we give it into a string. So we'll call the method loaderString. Firstly, let's create the result string that we'll be returning, and then create a buffered reader object that will read our actual file. So we'll create a new file reader with the file path that resides in the parameter for this method. We'll need to import these two classes, so let's hit Ctrl-Shift-O or Command-Shift-O on Mac to organize our imports. As you can see, we've got our classes imported now. We still have an error, however, since creating a new buffered reader object throws an exception. We'll simply surround it with try and catch. Great. The way that we're going to read our file is line by line, so we need to create a string that will hold a temporary line that we're reading. I'm going to call this string buffer, but another suitable name might be something like line. Now we need some sort of loop to read every line there is in the file we're loading. We can use either a for loop or a while loop, but I'll use the latter because it's slightly easier to understand. What I've written here as the condition for the while loop is essentially as long as readLine doesn't equal null. The readLine method will actually advance to the next line after it's done, which is why we need to set buffer equal to reader.readLine, since next time we call that method, it will read the next line. If it returns null, it means there aren't any more lines to read. We've finished reading the file. Inside the while loop, we simply need to append the buffer to our result string, along with a new line character so that we can separate the lines if needed. Finally, we'll close our reader since we're done with it, and release the file we just read. These two methods throw IO exceptions, so let's change our FileNotFound exception to an IO exception, since the IO exception class includes the FileNotFound exception. If you want to handle these separately or actually do something if an exception is thrown, go ahead. I'm going to leave it like this for simplicity's sake. We'll return our result, and we're done. That's all there is to file utils for now. So now that we have a way to load a file as a string, we can make a shader utils class that will actually load our shaders into OpenGL. We'll pop shader utils into the util package, of course. Primarily, we're going to need OpenGL 2.0 methods for this class, so let's import GL 2.0 statically. This class will also have a private constructor. Firstly, let's make a create method. This will create a program containing our two shaders, vertex and fragment, based on a string containing the source code that we'll provide. Firstly, we'll need to create a new OpenGL program. A program is a collection of different types of shaders that will work together. So in this case, it will contain our vertex and fragment shader. Once we've got our program, let's create the actual vertex and fragment shaders. These three and many other OpenGL create methods will return integers which contain the ID of what we just created. These IDs can later be used to modify various data that we've created, or put it to use. Now that we've created two shaders, we need to pass in the source code to OpenGL so that it can be compiled. Most things in this method will be done in pairs, for both the vertex and fragment shader. So we'll run the GL shader source twice for each shader, and pass in the appropriate string of source code. Next, we'll compile both of these shaders. Now we'll attach both shaders to our program, link the program, and validate it. Finally, we can return it, and our method is complete. Since shaders consist of source code, it would be really useful for us to see any syntax errors that we made when writing the shader. These errors will obviously stop our program from being created. And what we'll get is just a general OpenGL error. To do that, after we compile our shader, we'll check to see if the compile status is equal to false. GL false is OpenGL's version of false, and we'll need to import that. It's located in GL11, but instead of importing that entire class, we can just go ahead and import just the GL false constant, since that's all we'll need. Now back in our if statement, we'll print out an error message of our own, and then the actual shader info log, with a length of 2048 characters, which should be enough. Using system.error rather than system.out will yield red text in Eclipse's console, and should generally be used for printing error messages. Let's copy this if statement and adjust it for our fragment shader. Fantastic. Now we'll get really helpful error messages for our shaders. Since we want to create our shaders from files and not just strings, let's create another short method that takes in a file path for each of our shaders, loads the files as strings, and then runs the create method to create the shader program. There we go. Nice and simple. All we have to do to use this code is simply call shaderutils.load, specify a file path for our vertex and fragment shader, and we have our shader ready to use. We'll get rid of this code for now since it was just an example. Thanks for watching, and I hope you enjoyed this video. As always, a like is greatly appreciated. Next episode we'll be covering texture loading. Goodbye.